Welcome to Polonium Technologies. Today we're diving into one of the most popular stepper motor driver ICs used in CNC machines, 3D printers, and robotics, the DRV8825. We'll explore its features, pinout, interfacing, and applications, so you'll know exactly how to use it in your next electronics project. Let's get started. What is DRV8825? So first, let's start with the basics. What exactly is the DRV8825? The DRV8825 is a microstepping stepper motor driver IC developed by Texas Instruments. It's designed to control bipolar stepper motors with high precision and smooth motion. It's compact, efficient, and compatible with development platforms like Arduino, Raspberry Pi, and CNC controllers. It operates from 8.2 volts up to 45 volts, and with proper cooling, it can deliver up to 2.5 amps per coil, making it a great choice for both small and medium stepper motors. Key features of DRV8825. Now, let's talk about the key features that make the DRV8825 stand out. Microstepping up to 1/32nd step resolution for smooth and quiet operation. Wide operating voltage range from 8.2 volts to 45 volts. Adjustable current control using the onboard potentiometer. Thermal shutdown, overcurrent, and undervoltage protection for safety. Compact module design, ideal for embedded or DIY applications. These features make the DRV8825 perfect for precise motion control and automation systems. DRV8825 Pinout Overview. Next, let's take a closer look at the pinout of the DRV8825 module and understand what each pin actually does. Input pins, control signals. These pins connect to your microcontroller, like Arduino or Raspberry Pi. Step receives pulses to move the motor one step at a time. DIR controls the direction of rotation. Enable turns the driver on or off. M0, M1, and M2 select the microstepping mode from full step up to 1/32nd step resolution. Reset and sleep, used for power management and control logic. These are your logic input pins. They define how your motor behaves. Output pins, motor connections. These connect directly to the motor coils. A-out1, A-out2 for coil A. B-out1, B-out2 for coil B. Ensure you identify the correct coil pairs using a multimeter before wiring. Power supply and ground pins. These provide power to the IC and motor. VM motor, motor voltage input, 8.2 volts to 45 volts. VDD, logic voltage input, 3 volts to 5.5 volts. GND, common ground for both logic and motor power. Always add a 100 microfarad capacitor across VM motor and GND to prevent voltage spikes and protect your driver. Now that you know the pinout, let's see how to connect the DRV8825 with a microcontroller. Connecting the DRV8825 with an Arduino or similar board is simple. 1. Connect step, dir, and enable pins to Arduino digital pins. 2. Wire your motor coils to A-out1, A-out2, B-out1, B-out2. 3. Connect VM motor to motor supply and VDD to logic supply. Always add a 100 microfarad capacitor across VM motor and GND to prevent voltage spikes and protect your driver. Adjusting current limit for stepper motors. To protect your motor and driver, you'll need to set the current limit using the small VREF potentiometer on the module. Just measure the VREF voltage and use this simple formula. Current limit equals VREF times 2. For example, if your motor is rated for 1.5 amps, set VREF approximately 0.75 volts for safe operation and smooth performance. Applications. Because of its reliability and precision, the DRV8825 is widely used in CNC machines, 3D printers, and robotics. CNC machines. Accurate motion for X, Y, and Z axes in cutting and engraving. 3D printers, smooth stepper control for better print quality. Robotics, stable and precise positioning in robotic arms and mechanisms. Fully compatible with Gribble and Arduino-based controllers, so integration stays simple and performance stays consistent. Let's quickly recap what makes the DRV8825 such a great choice. It offers wide voltage support, up to 2.5 amps per coil, multiple microstepping options, built-in protection features, easy compatibility with microcontrollers. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe to Polonium Technologies for more electronics tutorials, IC breakdowns, and circuit design guides.